One last variation of conditional execution allows us to check not only for one condition and its opposite, but for multiple mutually exclusive conditions at once. This is done in Python with an if-elif-else block, where keyword elif obviously stems from a contraction of English words else and if. This is the general syntax for this construct. As before, it all starts with keyword if, followed by a condition, a colon character, and a set of indented statements to be executed if the condition is true. Then we have keyword elif, followed by a second condition, a colon, and another sequence of indented statements, which will only execute if the original if condition was false, and the elif condition is true. Finally, we may use keyword else, followed by a colon and another sequence of indented statements, which will execute if none of the above conditions were true. This last else block is not mandatory and may be omitted if needed. Notice that this construct allows you to include as many intermediate elif blocks as you wish in order to evaluate multiple intermediate conditions. In a given if-elif-else construct, only one of the internal blocks of statements is executed, which will be either the if block, one of the elif blocks, or the final else block. In other words, the execution of these blocks is mutually exclusive. Let's modify our previous examples to illustrate this concept. This program reads the user's input and converts it into a float. If the input is less than 0, it prints that it's negative. If it's exactly 0, it outputs the corresponding message instead. In any other case, it prints that x is positive. In all cases, the program ends with the end of program message. Here are the three possible execution flows for this program. Starting at line 1, the program prints enter number. In the first scenario, we assume that the user's input is a negative number set to -2. The program then goes through lines 2, 3, 4, and then skips to line 9. Here's a second scenario. The program executes line 1, and the user enters 0. The program continues with lines 2 and 3. Since the condition in the if part is false, it proceeds evaluating the next condition in the elif block at line 5. This condition is now true, so the program proceeds executing line 6, and then skips the remaining else block by jumping to line 9. And here's one last execution scenario. The program runs line 1, and the user enters a positive number set to 5. The program continues with lines 2 and 3. The if condition is false, so it proceeds checking the elif condition at line 5. The condition is also false, so it jumps to the else block at line 7. The program runs the body of the else block at line 8 and concludes with line 9. To sum up, the if-elif-else block allows us to evaluate multiple conditions until we find one that is true, for which we execute a dedicated block of code. The optional else block allows us to include a final set of statements executed if none of the above if or elif conditions are true. I hope you're now starting to visualize the additional flexibility that conditional execution unlocks. What cool interactive program would you write that leverages any of these three alternative control flow structures I introduced in this lesson? Think about it. In the next lesson, I'll show you more sophisticated and exciting examples. If you enjoyed this content, you may watch the rest of this lesson at computersciencecamp.com, linked in the description below. You'll be able to follow along with coding samples and problems in our embedded code editor. Drop your questions in the comment section below, and don't forget to like and subscribe to help support the channel. Thank you, and happy coding!